So this is the narrowest definition of an acid and a base. So the narrowest definition of an acid and a base is that an acid is a substance when you dissolve it in water. It increases the concentration of hydrogen ions, or H+. Whereas a base is a substance that, when dissolved in water, increases the concentration of hydroxide ions, or OH-. So that's pretty narrow. We can be broader. We can talk about Bronsted-Lowry. And here, an acid is described as a substance that can donate a hydrogen ion, and a base is described as a substance that can accept a hydrogen ion. So let's look at some examples using that definition. Let's see. Need the right kind of chalk. All right. So let's look at an example. All right, this is slightly pathetic. I'm going to use my glasses to write it down right. OK. So CH3COOH plus water, and I guess I should put that in aqueous, going to hydronium ion plus CH3COO minus, aqueous. All right, so what is going on here? So if we look at the things on one side of the equation and the other, you can see that this is an acid that has lost its hydrogen ion. So the hydrogen is gone, whereas the water molecule has gained a hydrogen ion, and so now it's H3O+. So we have an acid here. It's acting as an acid. An acid acts as a substance that gives up a hydrogen ion, and the water is acting as a base. It's accepting that hydrogen ion, and when it accepts the hydrogen ion, it becomes an acid in the reverse direction, whereas when the acid gives off the hydrogen ion, it becomes a base in the reverse direction. So in the reverse direction, hydronium ions is giving off a hydrogen ion to this base, reforming the acid, and after hydronium ion gives off its hydrogen ion, it forms water again. So that would be an example of Bronsted-Lowry talking about substances as acids and bases, whether they accept or donate a hydrogen ion. And this is the definition we're going to be using mostly throughout this unit. So